USB adapter. Okay, so this Wi-Fi adapter here is only $1 or $2. When you plug in the laptop, it will give you the second Wi-Fi. So that's what we have here. The Wi-Fi 2 is based on the Wi-Fi USB adapter, and Wi-Fi, the default Wi-Fi is from the laptop. Now on the box, it always say no internet because it's just between the box and the laptop. So we want the signal between the box and the laptop to be a minimum of 3 to 4 bars. The status is not updated in real time. If it is 2 bars or 1 bar, that means you are staying too far from the pile. Either you are staying too far from the pile, or there are too many still objects in between you and the pile that is blocking signal. So in that case, if you have only 1 or 2, another thing is all the antenna on the box. So on the box, there's an antenna, or the antenna on the box was getting loose. So you always need to check to make sure that the antenna on the box, let me see, and check with Louis to see if they are done with okay, so they are done. Actually, they put on pages number 2 earlier, so they are done. So all the lines are flat. Actually, you just saw some noise there. So if there's some noise, then that means in this case the accelerometer is not ideal. So I think we lost Louis. Let me close this and then reconnect. So the Wi-Fi to Louis' phone, if Louis' phone, the 4G or the 5G on Louis' phone is quick, then I can lose the signal. I lost connections to his laptop. So this is the internet connections to Louis' phone, which usually it will connect right away if he is in a 5G area. So his phone signal is quick, which means that okay, now it's good now. So okay, we go to start. This is pi number. Oh, should be pi number 2. Okay, it should be pi number 2. He's going to fix it now. Pi number 2. Okay, let me ask him this though. Let me put this chart here so that you can see my chat with him. Admit. Okay. Let me just upside down or not. Okay, so if the gauge is upside down, I need to put inverted. I'm not sure if it's okay. Upside down, that's good. Okay. Okay. Start. Okay. No, 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 no. So I see this out balance here. That's
Stage,
why
make sure you click and check them out. I see that we did just get joined on stage.
you need to be muted. Okay. Okay, let's see. I need to check this balance. Okay, so good now. Okay, so if you see a message here say stop, pause drive, up here with the red, then it needs to pause driving to rebalance the gauge. Okay, so we just wait for, so here is a pi monitoring process, not a simple test, not just a few blows. So D172, this is just a diesel hammer. Okay, so we start pi driving now. And the resistance, the required resistance is 226 kips. Going to click the wave speed detect to see if there's a better wave speed. So in the beginning, you can click on the wave speed auto detect. Let's see. Okay, all the records, accelerometer right now looking good. Two accelerometers are right on top of each other. If one of the velocity is off, like now it's off a little bit, that means one of them is not stable, as I mentioned earlier. So when it's not stable, you see that you just saw it earlier that if it's too much difference, the system will automatically turn off one of the V. You see, it's just yellow. Whenever you see yellow, that means the system detects that one of the accelerometer is way out compared to the other, and it would turn yellow on this box. It would turn yellow with the replay factor of 0, off, you say off. So that the systems would detect when is the data is not good, and it will detect, it will automatically turn off that channel. And during the pi driving, Louis will keep adding the penetration manually. So right now, LP is 20 feet below reference. It's a disturbance. It's 23 feet. And the soil is pretty soft. Is getting less resistance than earlier. So this is the resistance with each blow. The required again is 226 kips, and we are not going to stop when it's exceeding 226 though. Per FDOT specifications for this job is still utilizing the old the previous versions of FDOT specification. It was designed. This project was designed. The design was designed in 2017, and the designer requests to use the previous specification. The new FDOT, so it shows wrong acceleration here. That means one of the Accel is not stable. as I mentioned earlier, one of the acceleration is not stable. But according to ASTM, there's nothing wrong here. So this, let's see, the hammer may. Okay, they resume. So according to ASTM standard, you don't need to have two acceleration record. One is okay. So that's why. Okay, so Luis just mentioned they stop. Let me ask him why. So okay, so still pocket. So they are approaching the still pocket. The hammer lead is approaching the hammer pocket. So okay. You need to pause. Right. So that balance check will be up. Okay, so see, there's noise here. That indicates the accelerometer is not quite stable. On the V2, less noise, V1 more noise. It's supposed to be as flat as check noise. So when it's flat, there's no interference, it's supposed to be flat, like the F here. So F is this one. Let me turn F off. That's so you don't see F. So F here is supposed to be flat. Oh, so we forgot. No, let's see how I. Okay, so go ahead. Tied to an. Okay, oh, they run like that. Okay, they are ready. So resume. Okay, so okay, they resume driving now. So back to ASTM. ASTM required two good strain gauges and one accelerometers. Now, the specifications for these projects, as I mentioned earlier, require 2 feet exceeding the required capacity. So that's why we still driving. There are two estimates here. One is by the case method, IMAX case method, and the other is the signal match. So the blue is the signal match. The case method is preliminary. A signal match here is preliminary as well, because the signal match, this part is a little bit weird. This part is a little bit concerning though, because the toe is not quite toe is not quite sharp. The toe response not quite sharp. Now we have some non-proportionality here, but the toe reflection is not mirroring the impact. Now, as I mentioned earlier, this signal match during the drive, the signal match is very rough. We need to rerun the signal match in the office because this is instant signal match. And sometimes you have a good match quality, sometimes not good match quality. So match quality here, 15, 18 is not good. And if it's below 3, it's pretty good. So this signal match here, we'll need to rerun it later on. So looks like we exceed capacity on both parameters now. And I'm going to stop at 32. Oh, 32 now. Let's stop at stop. Okay. So let's review. Okay, so the last two blows is when they stop. So when they stop, the energy is always less, and when you have less energy, the mobilizer resistance will be less. So we are done with this part. We're going to move to next one, hand drive. Okay, so go ahead, move to pi 1. So copy is -5 elevation. Which is so reference elevation. Let me bring up the plan. Reference elevation is 13. Minimum tip is -5. So in order to meet minimum tip elevations, you only need to drive to foot mark 18, which is nothing. Let me bring up the plan. Plan. Let's see here. Plan. Okay, so maybe actually -15. 15 plus okay, -15. So we are at n-band 4. N-band 4. My mid tip is -15. And so we have to meet minimum tip elevations and required capacity and the specification requirement. So we need to meet 3 things. N-band 4, I'm sorry, N-band 4. We have to meet 3 things. Minimum tip elevations, we have to pass that. We have to meet the required capacity 113 tons, which is 226 kPa. And we have to meet minimum of 2 feet bearing capacities per the specification. the specification for this product. Louis again from this. So when one of the accelerators is not stable, most likely the end of that cable has some minor inner cut that is not visible, and which can cause the noise interference. So sometimes tying two ends of the cable together will help. Obviously, in this case, the best scenario would be to have a new gauge, but we only need one good accelerator, so we'll keep utilizing this one until later date when we repair the gauge. So I think at the end of the cable there may be some minor cut on the inside, which cause some loose wire. So the other day, the contractor, when they moved the hammer, when they were driving, the gauge is still on top of the pile, and they stopped pile driving to adjust the hammer, but they usually, when they adjust the hammer, when the gauge is still on the pile, the adjustment should be on the hammer should be minor, not so. Yeah, I think they're putting on the gauges now on pile number 1. What's going on, Louis? Let me bring this up a higher trigger. 160. They move the hammer too much out, and the lead caught the cable of the sensor. And when the lead caught the cable of the sensor, it may have caused some minor damage there. And again, to detect damage, so right now is all flat. To detect if there's a, okay, so Louis tied the two cables together. So it's all flat. Okay, that means there's no interference. But later on, the interference may comes back, because this is just when tying two ends of the cable together here is just a temporary fix. It's not a permanent fix. The permanent fix should be to fix the cable in our repair shop. But this is just a temporary fix. And so when during the pile driving, the noise may comes back, and the one of the accelerators may misbehave again. But for now, we'll keep using that accelerators. And the advantage of this system compared to PDI is that you can see the gauges, the status of the gauges, it is in good condition or not, just based on looking on this. So when there's no pile driving, the line are supposed to be quite flat. And in PDI, you don't have this monitoring gauge gauge the health checks of the gauges. Okay, so when see see those line, that's when they are carrying the gauges to different spots. So when carrying the gauges to different spot, it will of course zigzag the gauges and have those kind of interference, which is normal. We know that they are the gauges are in transport. Maybe the guy is climbing on the lid to the top of the pile, and those are the interference because they are climbing up, or maybe they're putting on the side number 1 right now. So when no pile driving, this balance check should always be open, so we can detect the issue with the gauge. So whenever they put on the pile, whenever they put the gauges on the pile. By the way, is the volume, when I talk like this, is the volume okay on your end, Caroline?
Yes, it's good.
Okay, good. Okay. Okay, so when they put the gauges on the pile, these two lines will move depending on the so right now it looks like they're doing something with side number 2. It will not stay. The two lines will separate depending on the offset, how good the hole will prepare. But after they finish putting on the sensor, right now I think they're putting on side number 2. Then after they finish putting all the sensor, the line is supposed to be flat. There may be some gap between the two lines, which is okay. It's just indicating the offset of the voltage. So whenever they put on the gauges, there will be initial voltage on the sensor, and we see later on. I'm going to get some water. So this is pi number 1. After they finish pi number 1, they will come back to pi 6, 5, and 4, which we drove 2 days ago. So pi 6, 5, 4, we drove 2 days ago, but never achieved the required capacity because the soil there is softer. So the soil in Florida is very interesting. It's done. So they are done with putting on the gauges, and then some minor separation between these two here, and you can see all these are flat, so it's good. So okay, go ahead, drive. So we will come back to pi 6, 5, and 4 after this. Those pi, even though they are right next to this pi number 1 and 2 here, and the marker on those pi were already 41 and 42, okay? But they never got the required capacity. And the template, as you see here, this is called the template. This is called steel template, and this is called pocket, steel pocket. This is pipe 2, which they just finished. This is pipe 1, which we are on now. Pipe 3, we finished. It got a lot of resistance on pipe number 3. It got really good resistance on pipe number 3. Pipe number 4 this way. I'm going back here. So accelerometers on number 1. Now have some noise there. Anyway, pipe 4, pipe 5, pipe 6, these bands. Let me quickly show the plan. Okay, so here we are on pipe number 1 right now. 2, 3, 4, 5, 6, 7, 8, 9. That band has 9 pi. We are testing all pi, which is common practice in Florida nowadays. Florida nowadays testing all the pi, not just a test pi, but all the pi. And pi 3, again, pi number 3 got really good resistance. Pi number 4, 5, 6, the pi marker went down to 41, 42, but the saws there are really soft, and we did not get the required capacity. So they removed the template. Because they start now. The wave speed looks very reasonable. So I don't think I need to do the wave speed auto detect. Keep the same wave speed. And see the. Okay, so one of the accelerometers is still not stable. So despite Louis tying the 2 ends of the cable, one of the accelerometer is not stable. Sometimes the 2 will match, the 2 accelerometer will match, and that's when coincidentally it's stable. Again, the program will detect if the records not too good, then they will turn it off. They will turn the accelerometers off. This pi number 1 here, so here see during the automatic signal match quality for these blows are really good. But again, this signal match here is preliminary. We always need to rerun the signal match in the office. This is a preliminary signal match. The case method is this. So this is signal match capacity, case method capacity. Case method obviously is preliminary. So whenever the next foot mark is coming up, Louis will hit this button here manually. So he will click that button, and he just did, and the LP will increase by 1. So you do that during the pi monitoring. So with this kind of speed, I think we will be able to finish all 5 pi by maybe 10:30. Okay, so it got good. Now it's dropped. So soil in Florida is really interesting. There's some hard layer and some soft layer. I haven't shown you the stresses. So whenever the stresses are too high, stresses here. If the stresses are too high, it will turn yellow. So it's really easy to see the warning. So if the stresses are high, it will turn yellow. If it's too high, it will. So our signal math is not quite not quite good on this flow. So I lost. Okay, I thought I lost. What's going on? Okay, we are hitting some interesting soil here because the toe reflections, this indicate kind of good end bearing. The toe reflection is not sharp, so it's good end bearing. Did it pause driving or not? There's not really noisy on the okay, what happened? Oh, okay. Okay, so this case number one, the accelerometer has some interference now. Okay, so they already finished removing the pocket, so we're going to resume. I was about to ask Luis to tie the end of cable again, but they will resume. So we'll keep doing. We'll keep. So. Okay. Yeah, soil here is very interesting. So when you have a deep toe reflection, that means soil is softer. And when you have kind of flat or raised up on the toe flexion, they possibly appear. Like, let me go back to the previous flow. So I'm going back to the previous flow. Like this flow, the toe reflection is kind of flat, that means more end bearing. But when you go down here, toe reflection is sharp, meaning the end bearing, not much end bearing. So the soil here is very interesting. So just soft and hard, soft and hard. So soil in Florida are unpredictable. It's very, sometimes the soil borings means almost nothing. Sometimes when you see the soil borings, it means almost nothing to us because the soils, the actual soils vary much more. Yeah, zoom now, change, stop. Stop, Luis. Stop. And we need to stop here because it shows some minor damage. Shows some minor damage here. And the beta is still okay, but I don't want to risk. So when you're driving into hard and soft soils, like this, I don't want to risk. I don't want to risk damaging the pi. But no more driving on this pi. Okay, so go back here, the previous flow. So here, so reflection is kind of the right point, and then for the subsequent blows, the toe reflection get earlier. So reflection gets a little bit earlier. That means the pi may have some toe damage. So that's the danger in pi driving in Florida when you drive through hard and soft layer, and you drive the one end of, then you're going to do a sketch later on. So go ahead, do pi 6. Okay. 4.6. Call Louise. Louise, let's see, call Louise. Oh, they cannot do pi 654 today. So that's it then. Okay, that's it then. All right, that's it for today. All right, thank you, everyone. Stop sharing. Okay, because they're going to take the whole day to remove the template. Okay, so they have not removed. They have not removed. Let's actually let me show the other pi for you. Okay, so pi 2.1 download. Okay, so that's it. Turn off. Turn off. Okay. Okay, let me show you. Close this. Let me show you pi. Let me show you the previous pi 654, which I mentioned earlier. That we haven't finished because no is 54. So this is pi 4. It has required capacity up here, but let me change it to this. So it have capacity up here, but it did not meet the minimum tip elevation. So we have to keep driving. So the minimum tip elevation is minus 15. And a reference at the time is this. So where the minimum tip would be around here, but then the capacity is dropping is in dropping change, so it doesn't meet the specification that says that in general increasing capacity, or at least flat. So if the capacity is dropping because the soil softer, as we keep driving, the soil keeping softer. So toward the end we have this. At the end we have this here, and same thing with pi 6 and 6 and 5. 6 and 5. This is 6. This is 5. So 5, actually 5, getting pretty close to the required capacity of 226. But again, we need to have a minimum of 2 feet into that requirement. So this is toward the end here. And the foot mark of this is 42, which is about 10 feet deeper than the neighboring pi. So the soil in Florida are very interesting. So that's it for today. Thank you all. Bye-bye.